Okay, I'm gonna do this worksheet number 5, but I'll start, before I do it, I'm gonna start with an extra question, because I wanna combine two ideas, what you did last time and this one, so it will prove a certain concept. So let's say you try to find a particular solution for this. So, similar to the previous one, you start with the homogeneous solution. N squared minus 4 equals 0, equals 4, then m equals minus 2 or 2. So the homogeneous solution in this case would be C1e to the minus 2t to the 2t. So, straightforward. Now we're going to do the concept we did last time, which is comparing coefficients. So yp, since this one is e to the t, we give it a letter a. This one as well, we give it a letter b. So that's your up. To be able to use this, I need the first derivative and the second derivative. First derivative would be aet minus be minus t, and the second derivative will be this. We put this here, so you start with the second derivative, which is this, and minus 4 of the actual function, so minus 4 aet, and minus 4 be minus t, and that would equal et e minus t. We look at the et first. It's a, the coefficients are a and minus 4a, and the coefficient here is 1. So minus 3a equals 1, a is minus third. We look at the b. So you have b minus 4b, and the coefficient also 1. Negative 3b is 1. B is minus 1/3. So that means that your particular solution would be a is negative 1/3, and also negative 1/3 e to the minus t. So your final solution, you take the homogeneous C1 e to the negative 2t, C2e to the positive 2t, negative 1/3 e to the t, negative 1/3 e to the minus t. Okay. I'm gonna erase this now. We've done it before. So now I'm gonna do it with the new concept, Wilkinson. That's another concept for finding dE. And it's pretty powerful. So we start with finding the homogeneous. We did, I don't have to do it again. So you start with the homogeneous, and we know that the answer for the homogeneous is the following. Now you need the UP, the particular solution, but we're going to do it in a different way. Hopefully we can get the same answer for this part. Your homogeneous has two sections, this one and this one. So you say my y1, you take the e part, so forget about the constant. And y2 would be this one, and forget about the constant. Then you take the derivative of this, and you take the derivative of this. Then W, which is the Wilkinson, you put y1, y2, you put derivative y1, derivative y2. So you put e minus 2t, and the derivative here, e to the 2t, and 2e to the 2t. Then you do the determinant, and you remember this times this minus this times this. This times this will give you 2e to the 0, because you're going to add the exponent, minus, you do this times this, and this times this will give you minus 2e to the 0, because you add the exponents again. E to the 0 is 1, minus minus is plus, e to the 0 is 1, so the answer is 4. So your W is 4. So I'm going to add it here. W is 4. So once you find W, you're going to put them all into this. Your particular solution is y2 integral y1 times whatever comes on the right-hand side. In my solution, I called it right-hand side, but for simplicity, you can call it like g of t. G of t would be right-hand side, would be et, e minus t. So the formula is y2 outside the integral, y1 times gt over w, minus, you go y1 outside now, and you integrate y2 times g of t over w dt. y2 is e to the 2t. W is a constant 4, so I can move it outside. y1 is e to the minus 2t, and the g is et e minus t dt. y1 is e minus 2t over the constant 4. y2 is e to the 2t, and the g is et e minus t dt. So this is 2t over 4 integral. Take this inside. This times this will be e to the minus t. This times this would be e to the minus 3t dt. Here minus 2t over 4. Take this inside would be 3t. And this times this would be et. So I'm going to erase part of the integral here, and part of this as well. So we continue, it's e to the 2t over 4. Integrate this one would be minus e minus t. Integrate this one would be e minus 3t over minus 3. E minus 2t over 4. Integrate this one, 3t over 3. integrate this one et. Take this inside, this times this, you add the exponent over 4, this times this would be minus, you add the exponent over 12. This times this would be minus et over 12, and this times this would be minus e minus t over 4. So the e to the t, you have to find common denominator 12, so I can make this times 3 times 3, so 3 e to the t over 12, and I'll put this one next to it. This one is negative t over 12. This is negative t. Common denominator would also be 3 over 12 e to the minus t. If you minus 3 minus 1 would be minus 4 over 12 e to the t. And this minus this, minus 4 over 12 e to the minus t. 4 over 12 is 1/3. And this is 1/3. And if you check, that's the same UP we found, so you just, for the final answer, you take it and add it to the homogeneous. So this is the concept, the new concept of Wilkinson, a different way other than comparing coefficients. So we're going to apply this question on the first question in your worksheet. Let's see if I can find it. Yeah. So question 1 in your worksheet, double prime 9y equaling negative 3t t squared plus 1. This is your right hand side, so I'm going to call it g of t. So we start with the normal way, finding the homogeneous. That would be m squared 6m 90. So m equals negative 3, and it's repeated. So your homogeneous solution would be C1 plus C2t into e to the minus 3t, which is eventually, this time the C1 e to the negative 3t, and C2t e to the negative 3t. So this is your homogeneous solution. Now we apply the new concept to find your particular solution. Y1, we take the first one without the constant. Y2, we take this one without the constant. We find the derivative of this, and we find the derivative of this, which is e minus 3t is product rule. So this is the derivative for the second one. Now we apply the Wilkinson, and remember it's y1, y prime 1, and y2 prime. Y1 is this, Y2 is this. The derivative is here, and the derivative is here. And now you find the determinant. And you know the determinant, you go this times this minus this times this times this. E to the minus 3t times e to the minus 3t, you add the exponents 60. And this times this would also be negative 3t e to the negative 60 minus. Now we go this times this. Negative 3 times t is negative 3t. And E becomes e to the negative 60. So it's e negative 6t, 3t e minus 6t, plus 3t e negative 6t. These two cancel. Then your W is e to the minus 6t, basically. Okay, so we found W. I'm going to add it to the collection of my variables here. So my W is e to the negative 60. So now we found the particular solution. y1 outside, integration y2 into the g function over the w dt minus well, it's better to start, it doesn't really matter, but it's better to start y1 inside first. And then y2 into the g function over w dt. Okay, y2 is t e minus 3t. y1 is e to the minus 3t into g, which is e minus 3t over t squared plus 1 all over w, which is e to the negative 6t dt. y1 is this, y2 is t e minus 3t times the g function over t squared plus 1 dt over w 60. Outside we have this. Now you notice that e times e, you add the exponents, it becomes e to the negative 60 and cancels with the bottom one. So now you're integrating just 1 over t squared plus 1. E to the negative 3t outside. Again, this will cancel with the multiplication. This one, you'll have t over t squared plus 1 dt. Integration of this is tan inverse. And integration of this is done u sub by letting u be the bottom, but eventually it's the ln of t squared plus 1 over 2. So this is your up. So your final answer, you always take the homogeneous plus the particular solution. So it would be C1e minus 3t, C2te minus 3t, plus the two solutions. So this is the answer for question number 1 using the new concept of Wilkinson. Now, the other questions you got, question 2a, t squared y double prime t y prime y 0. So if you don't see the t, it's just a normal homogeneous. But the fact that there is the t with the y's, it gets a little bit more. So I'll tell you what you're supposed to do. And this will be the same thing we do for all questions, all the next questions. You're going to let t be e to the x. And if you ln both sides, x would be ln t. The letter capital D is the derivative. Ty prime would be the derivative times y. And t squared y double prime would be d minus 1 y, which is d squared minus dy. You're always going to sub in these when you get a question that looks like homogeneous, but where there is like an extra t involved. Okay, so now we do t squared y double prime, we use this, d squared minus d into y. Minus t, which is minus dy, plus y equals 0. Then if I take y as a common factor, you have d squared minus d plus 1. So you have d squared 2d plus 1 equaling 0. That means that d squared minus 2d plus 1 would equal 0. So now we solve for this like a normal homogeneous, like imagine that's m squared minus 2m. So you have d minus 1 squared. So d equals 1 or 1. And that's like the same answer repeated. So if you structure the answer now, but I'm going to structure the answer in terms of x. Because I got these from switching everything to x. Like when in case of repeated, remember it would be c1 plus c2t into et, or yeah, t 1t, so because the answer is 1. This is how you would do it when it's, if it's t, but since we're doing it x, so we do the same structure for the homogeneous, but we put an x. So it's the same way you would do a repeated, but instead of the letter t, you put the letter x. So take this inside, c1 e to the x, c2x to the ex. So to get the normal answer in this case, ex is t, so that's c1t, plus c2, ex is t, x is ln t. So this here is your homogeneous solution. And that's the structure you need to follow, basically. Good? So we're going to do the next one. Question 2b. Now we're going to follow the same structure. So 2t squared y double prime, y prime, 2y equals 0. And you write this down. We're always going to write this down. So this, you will substitute d squared dy. This, you put dy. And this would be 2y. Now take the y out. Here you have 2d squared minus 2d left. Here you have d. Here you have 2. 2d squared minus d plus 2 equals 0. You set this to 0. Now, if you try and factor this, it's not going to work. So we'll use the quadratic. Negative b squared 4ac over 2a. Minus 1 and minus 1. Minus 1 squared is 1. 4 times a times c over 2 of a, which is 4. Four times 2 times 2, that's 16. 1 minus 16 is negative 15 over 4. The square root of 15, you leave it at the square root of 15, but since this is minus, we put an I. Over 4, so this would be over 4, this would be over 4. So your real number is 1 over 4, your imaginary number is square root of 15 over 4. So this is the, when you get a homogeneous with imaginary number, and you know the solution would involve sine and cosine. So I'm going to put everything together. For the sine cosine, it would be e to the real number. You can put the c1 first, doesn't matter. We prefer to put the e real number, c1 sine imaginary number, plus c2 cosine imaginary number. And c real number t, imaginary number t. But since we're doing it x, so we put x here. So, your real number is 1 over 4 times x. C1 sine imaginary number is root 15 over 4 x cosine root 15 over 4x. But since you have everything in terms of t, you need to switch to t. This one, what is this in terms of t? Well, if e to the x is t, e to the 1 over 4x would be e to the x to the 1/4, so that's t to the 1/4. Root root 15 over 4. Instead of x, we put ln t. Instead of x, we put ln t. So this is the answer for the question. Now the last question. Yeah, the last question, question 3, t squared y double prime, y prime, 0. We're going to follow the same structure. They also tell you that y at 1 is minus 2, and the derivative at 1 is 1. So, you write this down first. Instead of t squared y double prime, you go d squared minus dy. Instead of 5ty prime would be 5dy, 4y equals 0. Take y as a common factor. For d plus 4. You set this to 0. This is like squared. So the answer is minus 2 repeated. So now I know that my answer is, in terms of x, c1, c2, instead of tx, e to the minus 2, instead of tx. And if I take it inside, you get this answer. Now, we need to, so we got the answer. We need to switch everything to t. Now, the way you write this, e to the minus 2x is like e to the x all to the minus 2. Because when you raise to multiple exponents, you multiply them. And here the same, e to the x to the minus 2. So your homogeneous solution, e to the x, that's t, so t to the minus 2. X would be ln t, and this would be 2 to the minus 2 ln t. So here is your homogeneous solution. Or in this case, the only solution, because this is only homogeneous. Now I want to know what the constants are using this. But to do this, I need the first derivative and the actual function. So I have the actual function. I need the derivative. Derivative of this would be minus 2c1t to the minus 3. And this one, product rule, minus 2c2t to the minus 3. And derivative for the second one, 1 over t, c2t to the minus 3. Okay, so let's use the first condition. The answer is minus 2 if you plug 1 into this. Plug 1, c1, 1 to any exponent is 1. And you put 1 here, ln of 1, 0. So I figure out what c1 is. So I know c1 is minus 2. Now I use this condition here. The answer is 1 if you plug 1 everywhere. Okay, just plug 1 everywhere. 2c1 1 to any exponent is 1. 2c2 times 1 to any exponent is 1. And 1 and 1, they cancel each other at c2 eventually. That's 1. c1 is minus 2. Minus 2 times minus 2 is 4. And this minus this will be minus c2. Bring the c2 over, bring the 1 over. Your answer would be 3. So once you have what c2 is, you're ready to find the final solution. So your final solution is c1 is minus 2, t to the minus 2, and 3, t to the minus 2 ln t. And I just wanted to make sure, because in my answer I told you that this would be minus 3, not 3. I don't know why, because when we found the derivative for this being negative, yeah, it doesn't really matter, but I just wanted to make sure. Yeah, maybe somewhere I did something wrong. It's either 3 or minus 3, but that's the structure of how you do it. So please review this one and the previous one. Your quiz will be based on both of them. So make sure that you understand how we've done both of them. And I'll see you maybe Sunday. Bye.